Hello.
Hello.
How are we doing?
Good. How are you?
Good. I totally figured out that problem right after we left yesterday. And all I had to do was go back in the book because all the problems are written for that section. So when you go back to the beginning of the section where they're showing you stuff, it spelled it out basically, and it made it really simple for everybody to understand. We were totally overthinking it. Of course, that's what happens when you get caught in those things. All right, so now we're going to share the screen. And people are going to come in and they're like, no, not that problem again. Anybody else figure it out? I want toast. Everybody eat breakfast already?
No.
Anybody, your parents serve you breakfast while you're doing your lesson?
Yes.
No.
Nice when you're working and then breakfast comes in and is served to you, and it's great.
It happened to me once at the beginning of the quarantine. No, but
It's breakfast in the classroom, right?
technically.
I think Surin was onto it pretty much. This problem. But I got a very simple. I went back to the beginning of the section, and the way that it wants you to do it. And he even mentioned that it was could be the way we're interpreting what they want us to do. But I think I'm pretty clear on what they want. And it's as simple as, what do you do when you factor? That X factor thing? What are you trying to do when you X factor?
Well, it would have to multiply to 16 and add to 0.
Right.
Which means they would have to be opposites, and you
So
can't have two opposites to multiply to a positive.
Maybe I shouldn't talk about it yet. Maybe we should wait. Is Sir in there? Let's wait for him.
Can I give an explanation when we get to 8:30?
Yeah, I was gonna just do this. This is the M. This is the M plus the N, and this is the M.
Well, there's another way you can say, a negative number and a positive number don't multiply to a positive number.
Well, I mean, if you list all the factors, integer factors.
Well,
I don't want to get ahead. I don't want to get ahead. But you'll see 16 has a set amount, a finite amount of factors. And then you can play around with the negatives, and you will see either both factors have to be positive or both have to be negative.
No.
So you can't have one negative, one positive factor.
It has to be one negative, one positive to add up to 0, but it can't be for
No, I'm talking about the 16 factors, I said.
Yeah, I think that should be able to convince. So it's very hard to convince, though.
No. It's 8:30. We're going to get started. Okay, so the simple solution to that problem was this: is that x squared plus 0x, I like that, plus 16. You're trying to find two numbers that an m and an n that multiply to 16 and that add up to 0.
Add to 0.
Yeah, and so when you list your factors of 16, or you could have -1 times -16, or 2 times 8, -2 times -8, you'll see there's no way to get a positive 16 unless both signs are the same.
And to add to 0, you have to have two opposites.
Hold on. None of these will add up to 0, but then you get to the 4s and you're thinking, ah, okay, but then it's -4 times -4, right? And that's it.
-8.
There are no more integer factors of 16, and none of them can add up to 0. It's not possible. All right. So show that there are no integers m and n that satisfy both equations. That's what they meant. What were the equations? Here are the equations right here. Mn equals 16.
Sure, so I can't see.
M plus. Oh, right.
Seriously, that's it?
Yeah, that was it. I didn't look it up. I didn't find, when I went back to the beginning of the section, by the way, so those are the equations.
Mr. Rosenthal, that's what I said at the beginning.
These are the equations that we needed to say, though. I said before you got into Surin, hold on. Before you got in here, I said Surin was on to it. You didn't get all the way to this, but you were right on to it. Okay? But this is what I went back to so something to learn about textbooks and math textbooks specifically. When you're doing the problems and you reach a problem that's difficult, come to the understanding that they put that problem where they put it for a reason. Why would they put that challenge problem in this section? Because something they taught you in this particular section is being reinforced. So what I did is right after that, I turned to the very beginning of the section to see if I missed something, and sure enough,
it said, yeah.
They were talking about M and N in such a way that we didn't talk about it in that specific way. That made me realize that, oh, they did this. They said x squared plus ax squared plus bx plus c, right? So they were saying that m plus n have to be b, and m times n have to equal c. And I thought, oh,
I had a suspicion.
those are the two equations that they wanted. So then I said, oh, just do this and say, oh, this is what you're trying to solve. These are the two equations they were asking for, right? And it's just as simple as the things that we all know how to do when we factor is to think of all the factors of 16 that add up to, the middle term. And so that's it. And then you see, then that answers B quite nicely. Show that there are no integers. That's what they're talking about. There are no integers here. That's exactly what they're talking about. There's no integers here that's going to satisfy both of these. And
Mr. Rosenthal.
Simple as that.
Mr. Rosenthal.
Yeah.
When I said prove it logically, not algebraically, I had a suspicion that somewhere in the book they said that if you're trying to factor an equation, then the non-x terms must multiply to c. I had a suspicion that that was somewhere in the book, and all I was trying to say is, well, that's a basic principle. Let's just use that instead of having to prove it based on the equation itself.
And that got us most of the way, but we couldn't finish it off. So this is what we needed to hear yesterday.
No, that's what I was thinking.
All right, and so we almost got there. And I got there right after the lesson ended by going back and seeing what they wanted. And you also said that we might have been interpreting the problem incorrectly. So there we go. Now we're going to move on. Let's put that one away. All right, so then we did, oh, that's weird. This one was like a double print.
Oh, but it did the skate park one. On the zoo one.
Let's see. I don't want to, like you said yesterday, I don't want to do one that we already get the idea.
Repeat.
Rectangular, I think that's the same. They give you the dimensions of a rectangle, doubling the area, an X on each length at each dimension. No, that's the same problem. A museum has a cafe with a rectangular patio. That's the way the homework looks too. The museum wants to add 464 square feet to the area. Instead of doubling or tripling, they're adding a set amount. Doesn't matter. You still, once you have the area, oh, they don't give you the area. Oh, this problem's reverse. Try this one. So let me go back to the share screen. This patio one is in reverse. This one here. So let's all try to do this one. And I'm going to try myself as well. Museum has a cafe with a rectangular patio. I like to draw it. Okay. Oh, wait a minute. The way it's showing is not adding it the way we did before. It's just adding on one side.
No, then that'd be, wouldn't it?
This is why, this is why. Find the, okay, so the museum wants to add 464 square feet to the area. Are we missing something? Are we missing information that we should have had? Hold on.
Let me check.
Let me open up the book. Oh yeah. I must not have wanted you to do that problem because it's cut off. The problem's cut off. So everybody stop that problem.
Okay.
Yeah, because I don't have the full drawing.
Sort of figured something was out of whack when
Yeah, it was out of whack. Yep. School fair. Let's see if we could. These are all the same. Oh, here's the one I wanted. Now I remember, the grocery store one. Okay, now I remember. Okay, sorry guys. There, the grocery store one, number 72, the challenge. Let's all do the grocery store one. All right, a grocery store wants to, is it grocery or grocery?
Grocery.
Grocery. Grocery. Grocery. It's grocery.
All right.
No one says grocery.
I
That
knew
is
I was
not
throwing that in there, and I knew I would get that kind of response. Okay.
The only
Throwing
people
me a
who
bone, huh,
matter
Mr.
to
Rosenthal?
people who try to like yell at people for saying it a certain way.
I know, it's okay. Okay, a grocery store wants to double the area of its parking lot
Ooh, this is. Oh, I like this one.
by expanding the existing lot, which is not a rectangle. It's that L shape. By what distance X should the lot be expanded? Okay, good.
I like this one.
Actually, it's not really. Actually, one moment. Oh, it's not that. It's not. Well, actually, it's not that difficult, but.
Well, let's do the problem.
Okay, I still like it though.
Didn't we do this type of problem last time and the time
It's
before
different.
that?
It's different.
It's different. Daniel, don't you notice that the lot is not a rectangle?
Oh, yeah.
It is a strip.
So, 165 times 300. $49.5. What? Oh, yeah. What am I doing? So this would be.
You need to subtract that from the other one.
Yeah. So here we go. 165 plus 75. So I get this is 240. And then the other one's 375. So 240 times 375 is 90,000. And I'm going to subtract 49,500. To get the area of the current lot. Did everybody get 40,500 for the current slot? in square?
I did.
Okay. And that's not too difficult. It's the old lot.
I got 24,300.
Okay, you put that in the chat though, right?
Just as a reminder,
For the old law, I got
I suggest you turn off the screen share so that people watching later can see what you're doing.
Yeah, I am. Oh yeah, yes. The stop share when I'm doing it, yes. And I did that with my sixth graders as well. That is something I'm going to be doing. I'm just working out the problem while you are, and then I'll take.
Oh, okay.
Yeah. Let's see. Okay, so then I have that. So now, okay, I got it. They want to double the lot, so now I know what I need. I need 81,000.
Mr. Rosenthal, if you treated this as a rectangle, would you be able to?
I'm going to
No,
stop sharing
hold on.
now so I can start.
We are treating
Oh,
it like a
but
rectangle.
But I can't see the problem. I wasn't talking about that.
Nigel, I asked if we could just say mn equals 16, and you said we could not get to that. Well, I guess I was wrong if I did say that. Okay,
You did.
then I was wrong. I misinterpreted what they were trying to do. Okay, and I have no problem with that. Okay, here we go. See what I have so far? I added these two to get this medium rectangle, the area. Then I subtracted the store, which you see here. And that leaves me the old lot. All of it. That leaves me all of that area, which is 40,500. Now I want to double it, so I need double that is 81,000. Okay, and there. Okay, so I need 81,000 to be the area of the old lot, of the new lot, excuse me. So the new lot is going to be, how are we going to figure that out?
No.
That's how I did it. You make a complex thing. So you have x plus 75 times 375 plus x.
I like
And then you
that.
add x plus 75 times 165.
What about that area?
Well,
Plus,
that's not what I did. What I did was I got the bottom rectangle like all the way across, and then I got the smaller top rectangle.
There's an easier way than that too.
or you can do the area of the big one with the x
Yeah,
there.
and then just subtract the small one. Yeah, that's the
minus
easiest
the
way.
yeah, minus the area of the small one. Yes.
Yeah, that's the easiest way.
Okay, let's do it that way then. So I have x plus the 240 times x plus the 375 is the area of the whole big rectangle, and we have to subtract the grocery store, right?
Oh, the grocery store. Ah, yes, the grocery
Because
store.
the entire lot needs to have an area of 81,000. Now, what was the area of the grocery store? 49,500, right? Okay, and that has to equal 81,000. That has to be the new area of the parking lot, which is double the area of the old one, old lot area. Okay, so now we can get started here. So I have x squared. I have 240x and 375x, which is 615x. And then I have to multiply 240 and 375. No, oh, I was 90,000. Minus 49,500, which is what we already have here. So it's plus.
Not 49,500, just 40,000.
No.
49,500.
49,500 is the grocery store.
Oh.
And And you have to subtract that from 90,000.
Well, I didn't do it that way, so.
And that's equal to 80.
1 moment.
Now I subtract 81,000.
Oh, I see.
So I have 4,500 minus 81,000. And it's just minus 40,500. Go. So now the trick will be, what are the factors of this that are going to give me 615?
What is going on?
Yeah, please.
Soon.
Okay, so now we have to figure this out. What are the numbers that are going to make that? Everybody should be trying to find out the two factors that add up to 615 and that multiply to 3,500. So maybe start by dividing by 100. 405 times 100.
But then it would be 6.15, and that's decimal. We don't want that.
What about 40500 divided by 90? 5.
Isn't it easier to just plug these type of problems into the quadratic equation?
Oh, you're right. Totally. Thank you. Thank you, Daniel. You're right. When it's, unless you could figure it out faster, you're right. Let's do that.
I've been waiting to use the quadratic formula for this entire class.
There we go. Now we see a good purpose for it. 615 squared minus 4 times 1 times negative 40,500 all over 2 times 1. Let's start simplifying it down. So 615 squared is 378,225.
Mr. Osler, are you using the calculator?
Yeah.
Well, then in that case, if that's permitted, we could just plug the entire equation into a calculator
Not my
immediately.
calculator.
Well, Google calculator would serve the purpose.
Okay, go for it. 81, so 162 plus 162,000. Okay, I got 540,225. I'm going to take the square root. It's 735. So, and you can't subtract it because you'll get a negative. So it's going to be adding. So I'm going to take away 615 and then divide by 2, and I got 60. X is 60 feet. Done. Nice. That was rewarding.
Same answer here, Mr. Rosenthal.
Excellent. I'll take questions. So you can see how, I mean, this problem starts off not seeming to have anything to do with a parabola. And we can use, you can see how you can use the quadratic to solve these types of problems for, in this case. And there might come a day where you're going to need to solve a problem like that, and you'll remember that you can make it a quadratic. All right, let's move on. Let's actually get to the lesson. That would be good. Solve ax squared. Let me go back to share screen. So now we're going to be doing this with a coefficient for a. And I don't know how Mr. Canals taught that to you. But look, 4.4 is about when the a is something other than 1.
You're saying we wouldn't. Oh, right.
So, and a lot of
Except
students are going to need review on that. You forget how you're supposed to factor that. Now,
yeah, you just do AC, wouldn't you?
Well, let's see. So let's talk about how this gets factored. So here, let's see how the book. Now, listen. The next challenge problem might come back to this. This is where I went for 4.3. I went to this very beginning section that talked about it this way with an M and an N like that. So the challenge problem might have that same thing where it needs to know that. So let's look at how they're breaking it down here. Okay, so I'm going to write it on my board and then I'll stop sharing the screen. So just take a look at that. I'll read it out loud. To factor ax squared plus bx plus c, when a is not 1, you have to find integers k, l, m, and n such that ax squared plus bx plus c is equal to And there you have it. It's kx plus m times lx plus n. And then they expand that out. So now if you multiply,
KLX.
yeah, so what you see after the equal sign, after the factored form, is when it's expanded out, you see that you get KLX squared plus, and then they factor out the KN plus LM.
Did you get a whole number for the
Plus n.
last problem?
Yes.
I get square root of 465, which is an irrational number.
No, it shouldn't have been.
It's 60. The answer's 60.
It is 60.
Mr. Rosenthal, I noticed an interesting grammatical quirk. I noticed an interesting grammatical quirk on that first page.
I'm an idiot.
We are not in English.
Don't
class.
say that.
No. It's a very interesting grammatical quirk. You see, it looks as though they put. It looks as though they're writing a series of 4 items. And yes, there we go.
Okay, I'm going to stop sharing my screen right now. Okay, so let's go ahead and expand this out together. So you have this first multiplication there. They're saying that you should be able to factor ax squared plus bx plus c into these 2 binomials, which are the factors, right? They're being multiplied, okay? And then when you do this, you get kx times lx is klx squared. Be careful here. Kx times n is knx, knx 1070. And then here you have mlx, and then you have mn, just like we had in the other one, mn. Okay? And then what they're saying here is that you can, since both of these have x, you can factor out the x. Okay, so you have klx squared plus kn plus ml.
What is the L?
It's some coefficient of x there, which could be 1 or it could be something else. You know, and then when you multiply it to the other one that has a coefficient, which could be also 1, okay, that's what gives you the A. If you multiply this out, it's coming from this original one. They're equating this with what we're getting now. When you factor something that this quadratic here, when you factor this polynomial and it has a coefficient here that's not 1, you're going to get something, you're going to get coefficients here that could be 1 or some other non-1 number, k and l. Right? So you can get 3x plus 2 times 4x minus 7. They're saying the 3 and the 4 here are the k and the l. The 2 and the negative 7 are the m and the n. It's just an example of where there would be numbers. Right? And then when you multiply this, you would get 3 times 4, that's the k times the l. You would get 3 times 4 times x squared. Plus you would get 3x times negative 7. So you'd have 3 times negative 7 times x. Plus you would have 2 times 4 times x. Right? And then you'd have plus 2 times negative 7. So there's your m and your n. There's your mlx right there. There's your knx right there. And there's your klx squared right there. That's what k and, so if you want, if it helps you to look at numbers, and all of that gives you the A, B, and the C, because this is going to be the A is going to be 12, right? In my numerical example. They factored this out here. They said that since both of these have x in it, right? You're going to add the middle terms, aren't you? And how do you add the middle terms? Don't you add their coefficients?
Yeah.
Right? So this would be 3 times negative 7 plus 2 times 4, right? Times x. That's kind of what we did here.
It should be negative 21 plus 8.
Right? And then this is 2 times negative 7. And then, yeah, you can go 12x squared plus negative 21 plus 8 is negative 13.
So erase the plus.
But we can leave it there just so that it looks like a plus. So you can see what is B, what is C. In this numerical example, you can see A is 12. What do you notice about these two numbers? They're factors of 12.
Yeah.
Okay, they're factors of 12. All right, so 3 and 4 were the what? They're the K and the L from up here. All right, okay, and then let's examine this negative 13 or this negative 14 here. The negative 14 was the M and the N. Okay, so the M and the N have to be factors of the C. So the M and the N have to be factors of C. The K and the L have to be factors of the A.
K, L, M, N.
But look at your middle terms. Your middle terms are made up of, let's look up here, Kn and Ml. So they're trying to
They're all of the coefficients.
they're trying to show you how, so that you're the whole, why are we doing this? Why are we going through this routine? We're trying to show you why your teacher taught you to multiply those two. Why are we doing that? Why are we multiplying that to see what factors of the product of AC
KLMN.
add up to be?
The factors of KLMN are Kn and Ml, and that they add up to the coefficient.
You need a K times an N to add with an M times an L.
You need to multiply KL and Mn and then factor out the Kn and the Ml.
So what they're showing you here is that when they in order to get this combination here to add up to B, you need all four of these factors. So the only way to get the M and the N and the K and the L to is to multiply them to some number where all of these are factors of it. So you need a number when you're doing your what multiplies and what adds. You need this to be K times L times M times N. You need those to be, you need to pull out factors that add up. So you're going to need to pull out a, let's see, a K times an N that multiplies with an M times an L. You're going to have to multiply those.
Add to the middle coefficient.
Add up to Kn plus Ml because you're going to get Kn plus Ml. So remember, you're trying to find two things that multiply. If you only use the C like we've been doing last chapter, you're only going to get the M and the N. And so you're not going to get what you need to add up to.
Of course, in the last chapter, K and L were 1. So.
Right.
Don't you need to do AC in order to factor?
Yes, you need to do AC,
what
but
we're
A is KL and C is MN.
Look, wait, hold on, David. What is A? A is KL, right?
Mm-hmm. Yes.
C is MN, or they're factors. KL are factors of A. MN
Yes.
are factors of C.
Yes.
Okay? So if you're going to have to find over here two things, we know we're going to have to add the middle terms, which are Kn and Ml. In order to do that, then you have to have something that multiplies, that is Kn times Ml, right? So you're going to have a number that's made up of all four factors. And so you're going to have to multiply the A times the C to ensure that you get all the factors in there.
Yes, I see how that would work. So KLMN is a number to which it's supposed to multiply, and Kn and ML are the numbers to which it's supposed to add, like the pair of numbers, like usual. And they are they are factors of KLMN, so they're KLN.
Yeah.
Well, wouldn't they be KLMN?
Yeah, it's going to be KLMN. Yes.
Seems a rather intriguing way to put it.
It is, but see, the thing is in algebra classes, they tell you by algorithm, this is what you do. And then when you multiply this one to that one, and students can learn it and get all of these problems correct without doing what we're doing here. And so, but because we went through our geometry class and we want to know why these things happen, now we're doing that. We're discovering why do we multiply the A times the C and then take factors of that product. The reason is because when you multiply the A, which is KL, and the C, which is MN, and you multiply those, then you can, when you have to add up to Kn plus ML, then you're going to multiply Kn times ML, and it will give you KLMN. When you multiply these, you get this, and when you add these, you get that. Okay?
Oh, yeah. No,
You cannot get this, you cannot add this with just M and N here. You need all four factors so that you can get this combination of those factors. Right now, the commutative property says I could have done KL times MN, which is what you're doing here. Or I could have done I could do KM times LN. Any combination because of the commutative property I could have done, but we need that combination. Why do we need that combination? Come back here. Look at what happens when you distribute. This times this, it's in the middle. So KX times N, you're going to have to multiply and get KNX. In the middle here, you're going to have to get MLX. When you add them, and these are both X's, you have to add Kn and ML. You have to add Kn and ML. So because you have to do that, you're going to also, to get this, need to multiply Kn times ML. When you multiply Kn times ML, you get, see, I'm working it backwards. You have to get this, KLMN. You have to get KLMN. In order to get KLMN, since A is made out of KL, as you can see here, and C is made out of MN, in order to get KLMN, we multiply the A times the C to get KLMN. Okay, so that's working it backwards. All right, let's move forward. Any questions about that? So I know that was deep, and for some of you that might have been confusing. In the end, what you're going to need to do algorithmically, is that a word? Okay, is A times C.
Algorithmically,
to get what your product is going to be of two factors that add up to B, the middle term. Okay? All right, we made it through. Okay, okay, share screen. I don't even know what that is. Oh boy, I shouldn't have done that.
It's a numerical explanation, I think. Uh-oh.
Hold on.
Still can't believe they used an Oxford comma on the first page.
What?
Are you against the Oxford comma?
he is very against
Vehemently against the Oxford comma.
Oh, I disagree on the contrary. I'm a huge fan of the Oxford.
I'm a huge fan of the Oxford.
Wait, don't get it.
I feel as if it's quite
No, yeah,
professional.
please, let's not.
I don't want him to wait till the
Do
Oxford
that in
comma.
office
So
hours,
the rest of
actually.
the-
Well, I have a sentence that'll make you appreciate the Oxford comma a little more that I'll tell to you head
He's
off.
heard of it, trust me.
I'll rearrange it so that it doesn't need the Oxford comma. Then you'll
There you go.
realize just how useless it is.
Let's not, okay, let's do that. You know what? I want to hear that. I want to hear that. Let's do that.
That's so
Ooh, you know what I forgot to do is hit record. So
It's
that
recording.
problem,
recording.
it is recording?
Yeah,
Yeah.
it's recording.
Oh, okay, it's just not recording to the cloud, but I'll take that. I'll just let it go this time, that way. Okay, so go ahead and factor this one here, please. Example 1, while I bring it up on my screen.
Oh look, ducks.
Ducks? What?
Ducks, turtles, and waffles.
And I'm going to stop the screen share because now I have it on the board. Okay,
This is easy.
So like this. Okay, but now you should start seeing it as, what is 5? That's KL. What is 6? It's MN, right? So when you multiply, you get 30. That is KLMN. Okay, your middle term is negative 17. Okay, 1 and 30, 2 and 15. Yes, negative 2 times negative 15. Okay, now what do you do? Okay, so now what do you do? What you're doing is what is this that we found? What was this combination?
KL and MN.
This
Wait,
was
no, KM and
KN.
KM and LN.
and ML.
Okay.
Yeah, it doesn't matter. Okay.
I don't know how they view it.
This has to be the addition of them, right? Okay.
Yeah.
Now you found those. You found what KN and ML are. All right. So now, what does that mean? That means that I'm going to split this negative 17x into those two pieces. Minus 2x minus 15x plus the 6. And it doesn't matter.
It's x minus 2 and x minus 15.
If you notice, I have not changed the value of my original polynomial. I have not changed my first term. I have not changed my last term. I didn't really change the middle term's value. I split it into the two that I wanted to be split into. Because I did that, because this is Kn and this is K, remember this is KL and this is Kn, they're going to have a common factor, okay? And even if that common factor is 1, all right? And then, of course, with the x, we were always able to take out an x, even when we didn't have a non-1, even when we had a coefficient.
Mr. Rosenthal, to find the original coefficient of the x, what did you do? You took the common factor of what? Greatest common factor of which ones? Well, in order to find when you factor the coefficients of x, how do you?
Here.
X squared, I mean.
You did KLMN, which is the 5 times the 6 is 30.
No, x squared, Mr. Rosenthal. When you're factoring it, and you have, if you factor it, for instance, into 5x minus 2 times x minus 15, how would you find the coefficients of x in the factor form?
I'm doing that now. I'm showing you. You're going to factor by grouping. This is Kn, this is ML, this is Mn. What's in common is the M here. What's in common here is the K. These are the coefficients. That's how you're going to get the coefficients. So now what's in common with these? 1x.
Okay.
So K is 1. What's in common here? 3. M is 3. So you now know what those are. But watch how, you don't have to think about it that way. All you have to do is factor these two. Factor an x, and you get 5x minus 2. Okay?
Factor a 3x.
Oh, so would you just factor the first combination of terms?
Minus 3, because I always use that sign, minus, and then 3 is in common, that's the m, and then negative 3 times 5x gives you negative 15x, negative 3 times negative 2 gives you positive 6, and now look at what matches. In this product minus this product, 5x minus 2 is in common. X minus 3 is the not.
So Mr. Rosenthal,
So that's what you have to do. Okay. All right.
So did you factored out one moment? I'm trying to. So you factored out x from the first two terms, and you factored out the greatest common factor from the second two terms. Is that how you did it? So from the first two, 5x.
Yeah, the GCF and the GCF here. Using
Yeah,
that, I copy.
Yeah,
I make it a rule. Some teachers don't. I always use that sign. And because I always use that sign, it makes it I don't
So
about it. I'm always going to use that sign.
so the GCF. So you factored out the GCF of you factored out the GCF of 5 and 2 multiplied by x.
No, of 5x squared.
Squared and negative 2x.
And the GCF of their
negative
coefficients
15x.
is 1,
Oh,
so
15x.
that's why you factor in.
Not just the coefficients. It's the entire term.
And he factored out the GCF of the negative 15x
Yeah.
and the positive 6.
Yes, but you would factor out an x anyway, but the coefficient of the x is the greatest common factor of 5 and negative 2, which is 1.
Okay, yes. But 1x is the greatest common factor of 5x squared and negative 2x.
By the way,
That's even more confusing, David.
my k was right there, by the way. Remember I said my k was 1? There it is. Okay? Remember I said my m was negative 3? There it is right there. Okay? There's my m. Now I know what my n is. My n is negative 2. I know what my L is. My L, here's my L, here's my K. Okay, here's my M, here's my N. That's where they went. Okay? All right, now, for those of you who don't like all the depth, it's just too much to follow. We forget all this and we just go algorithmically. It's actually easy to do algorithmically. But so many students forget this. So it's because you don't know why it's happening. Okay, step 1.
I prefer the depth.
Hold on. Step 1, multiply 5 times 6. Use the middle term. Now do the problem like you normally do. Find those factors of 30 that add up and you find those. Then next step, rewrite your polynomial but split your middle term into these two. Okay? Minus 2x minus 15x plus 6. Okay? Now, factor these two separately from those two. What's in common is just x. Then you get 5x minus 2. Use that sign, minus. What's in common with these is a 3. If you did it correctly, it should be 5x minus 2, the same as this one. Check it. Negative 3 times 5 is negative 15x. Negative 3 times negative 2 is 6, so it checks out. Then, final step, what's in common with these two is the 5x minus 2.
So you add the coefficient.
What's in common is the x minus 3.
Add the coefficient, yeah.
So algorithmically, without the little notes in there, the problem doesn't take too long. That's called factoring by grouping. Now, I don't know how Mr. Knaus wanted you to do it. He probably wanted you to do it in
He did grouping. He did grouping.
Oh, he did it this way?
He did grouping. He did several different ways. Completing the square, grouping, X factor.
Okay. Questions? This is what today's lesson's about, folks.
I think he also did like that square, a grid, and you put
That was completing the square.
Wait,
Yeah.
Mr. Rosenthal, how did you get from x parentheses 5x minus 2 to the thing after that?
He added the coefficients.
What's in common?
Same basis.
Look, Daniel, if you notice, that's multiplication and that's multiplication. So this is one whole term, actually.
It's like xy
Hold on.
minus 3y.
Hold on, David. Hold on 1 second. This is one whole term, and this is one whole term. Do they have a factor that's in common, a common factor?
5x.
5x minus 2. So that can be factored out, which you see here, and what remains is the x minus 3.
Oh, I remember when we did this last year.
That thing in parentheses, that's variabilize that. That's y. xy minus 3y equals x minus 3y.
That's right. That's right. Okay? All right, and we're going to need to practice this. I mean, this is something that everybody has to know how to do. And I know a lot of you already know it, but for the rest of you, I want you to think about if you get it, if you really get it already, I want you to try to put in the notes that what is K, what is L, what is M, what is N, and that's a new activity for you. So those of you that already know the algorithm and you're not getting much out of this, what you could get something out of is every time you do one of these problems, you tell me what K, L, M, and N are. That's the extra challenge. You tell me what K, L, M, and N are. Okay, so all of you that already understand the algorithm, you tell me what also, after you're done, or while you're doing it, identify KLMNN. That's your new challenge. That's how I'm going to make it a little bit.
Wait, so Mr. Rosenthal, in this problem, K and L are 5 and or what are K and L?
K and N are the coefficients. No,
Okay.
wait, sorry. M and N wouldn't be the coefficients. K and L are the coefficients.
Okay, and then what is M and N?
So,
The non-X.
all right, let's go back. Let's go back. Okay, while we're doing this problem, we know that this 30 is K times L times M times N. Okay, and we know that this is Kn plus ML. So we are looking for a K times an N plus an M times an L and a Kn times an ML. Okay, so K times N is -2, right? And -15 is the M times the L. All right, let's see. Then we separated it here. So this was Kn. We know that 5A was made of KL, right? We knew that the C, the constant on the N, was Mn. And then we know that the -15 is the ML. What's in common with these is the K. So that's the 1 here. So 1 is K. So K is 1. We got the K. Okay. So then L must be 5, right?
Oh.
If you know what K is here, then you can get what M and N are. Oh, that's an interesting way to do it. I never even thought about that. So now look, if I know that what's in common with these is the K, and I now know that it's 1, when I look at that, 1 is in common, then I know K is 1. So I'm going to fill this in with a 1. That means that if the -2 is 1n, I know that n is -2. And I know that L is 5. Look at that.
Which means 5, M has to be 3.
If L is 5, then M, the only one I don't have, must be -3.
-3, yeah.
Look at that. So without even doing these steps, we just figured out a way to do it.
Oh, but how did you get K if there are 2 M's?
What method did you find to do it? What method did you find to do it?
Oh, hold on. I don't know. We just discovered a new method. And then we know that it is Kx plus M and Lx plus N is how it factors. Okay, so now I know if K is 1, it's 1x plus -3, so -3, times L we said is 5, so 5x, and N is -2. Look at that. I didn't have to do the grouping.
Yay. Wait, but Mr.
Hey,
Rosenthal,
how did you find K,
All right,
L,
I'll go
M,
back.
and N?
I'll show you. Let me go back. I just figured this out. This is so cool. This is great. Sorry. I'm so excited.
Well, so am I. I just want to know.
Well, I'm hungry and I want to move on.
We will. Hold on. Okay, so we know what do we know that did we learn? We learned that our beginning term is KL. How do you know that? Because when you multiply these, you're going to get KL, right?
Yes.
Okay. Your last term is going to be MN. We know that. When you are doing this, we know that in the middle 2 terms have to be Kn times ML. How do I know that? Because when you multiply this to that, you're going to get KNX, and in the middle you're going to get
MLX.
MLX. So this plus that is going to make your middle term, Kn plus ML, right? So that means that the -2 is the Kn, and the -15 is the ML. What happens if you switch them?
Yeah, wouldn't it be different if we switch them?
No, it won't be different if you switch them.
Not the final result, but the way to get there.
The way to get there is different, yeah, but you'll get the same final result. Okay? So then what you're saying is when you solve for KLMN, they could be switched.
Yeah,
So,
like Kn and MNL will be different numbers.
So KL is interchangeable, and M and N are interchangeable. Okay, so K could be L and L could be K.
So how are you solving it, Mr. Rosenthal? Then once you've determined that those,
You just need a combination of K and L. Once you know what K is, then L has to be the other factor. Once you know what M is, N has to be the other one.
how do you find K?
Okay, let's go back to that. So how do you find K? Well, I know that the -2, I'm going to say that that's the Kn, right? And the -15 is the ML. Okay, what's in common with the first two terms?
Okay.
Or you could say that what's in common with the first and third terms because KL and ML have
Let me finish my thought. You know here that K is what's supposed to be in common. Actually,
Yeah.
actually look at them. What coefficient?
1.
1. So now
1.
K has to be 1. Erase it, fill it in, and mark that K is 1. Now, how do you get a 5 if K is 1 and 5 is K times L?
L is 5.
L is
L has to be 5, and also you have N has to be -2. And once you have that, if N is -2, you can either do it here. -2 times N,
-3.
negative 3.
M is -3. Now you go back to this and just fill it in. 1x, M is -3, L is 5, so 5x, N is -2. There you go.
Yay. Can
Now-
we move on and do some practice problems?
You would have to practice this method for it to be efficient.
Wait, but how is K1 if there are two M's too? Shouldn't M also be 1?
Right here, look. 1.
M is -3 because look at that. N is -2. And -2 times M equals 6. Therefore, M has to be -3.
Now, what if I would have switched it? What if I would have made this ML?
What if you made M1?
Hold on 1 second. And this, if that was ML and this was KN, how would that change things? Well, now what's in common is not the K. It's the L is in common, right? So now L is 1.
It would just switch the places of the factors.
So is
Mr.
something
Rosenthal.
always 1?
No, Daniel, that's not the
It would be
point.
I think it would be more interesting
L and
if
K are
with the
interchangeable.
-2x and the negative.
What? 1 second, Daniel. The reason that M or N or whichever one you said isn't 1 because it has to multiply to both -15 and 6. So the greatest common factor of -15 and 6 is obviously -3. So it can't be 1. Because if it were 1, it wouldn't multiply to form -15 and 6.
Mr. Rosenthal?
And it's not always 1. The reason it's 1 at the beginning is because 5 is a prime number. Yeah.
Guys,
1.
just a teacher tip. It's very tough to talk about abstract stuff without providing a visual. So you
Mr.
know.
Rosenthal?
And I had to learn that as a teacher. That's not necessarily obvious unless when you think about it, you realize, oh, you understand it in your head and you're describing it, but without a visual, your listener is often not following. So I just want to not spend the time doing that. So when we switch these, by the way, it just switched my result, and the commutative property holds true.
Okay.
All right, let's move on. I think
Yay.
people are over this, and we're going to be out of time in 6 minutes. So I'd like to move on.
That's good.
I know we said we're not in a rush, but also we can't take infinite time to do stuff. Let's go to this next problem, and everybody do that. This 3x squared problem.
Yay.
You can do it algorithmically, and if you want to do it with this other method that we just discovered, go for it. And I'm going to stop sharing, because I have it on my board now. Okay, so multiply. -21 represents LMN.
Easier and way faster to do it without thinking about K, M, L, and N.
You get that? No, yes, exactly. So now I have -1 and 21. So I rewrite -1x plus 21x, and that together makes 20x minus 7. What's in common here is just x. So I get 3x minus 1 plus what's in common here is a 7. Copy down this one and check it. 21x minus 7, yes. What's in common is 3x minus 1.
So x plus 7 times 3x minus 1.
There you go. Any questions about that?
No.
We don't say no, we just say yes if you have a question. Anybody?
One moment, I'm still doing.
What are the KLMN?
Okay, you want to know. Okay. K and L in any order would be, this is what? This is Kn plus Ml, right? Your first term here is KL. This is Mn. Okay, this is Kn. This is Ml. So K
1.
K is what's in common with the first two terms, which is 1 numerically. Okay, now that that's 1, L is 3.
And it's negative 1.
N is negative 1. And then here, if pick one of the ones you know, L is 3. In order to get 21,
7.
it will have to be 7. Okay, so this one, this 3 here is my L. Negative 1 is the N. The 1 here coefficient is the K. And the 7 is the M. There you have Ln Km.
Yay.
All right, any questions?
Just drumming my fingers on the keyboard, on the space bar, and then suddenly a ton of different things started happening. I'm like, whoa, I didn't realize the space bar was so powerful.
Yeah. All right, so there's more to practice, which you're going to get in your homework, but we're running out of time, so I'm going to close it here. Tomorrow, now that we got conceptually the depth, tomorrow is probably going to be more, let's get through it and get to the application, okay? So I'm calling it now. Have a wonderful day, and I'm on office hours.
Thank you,
Okay.
Mr.
Thank
Rosenthal.
you.
Thank you, Mr. Rosenthal.
Oxford,
Hey.
comma.
Thank you.
Good.
Hey,
We have
Surin, I have a sentence for you.
Time to debate, huh?
I love my parents, Jamie and Jenna. Is that saying you love your parents and Jamie and Jenna, or your parents named Jamie and Jenna? Without that Oxford
Well,
comma,
if you
what the
moved,
sentence is
Let me,
about.
okay,
I've got an easy and quick fix for you. I've got an easy and quick fix for you. It would be, I love Jamie, my parents, and Jenna. Done. It's
No, but
the
you have
exact
no
same
idea what the
sentence.
sentence is about. You don't know what the sentence is about when you have the first one, so it's impossible to figure out how to fix it if you don't
But
know.
that's the author's obligation. If the author wants to convey a message, either one of those sentences would work, and you don't even have to use the ugly, hideous, redundant Oxford comma.
How is it ugly and hideous? It's just a freaking comma. You use them in your everyday
It's
life when you're writing down words, and it's impossible.
No, you